So now that we have refreshed your memory with two variable systems, this is when we have two variables and two equations. We're now going to take a look at when we have three equations with three variables. So remember, our two variable systems, this was points on a line where lines intersect. With our three variable system, this is going to be a point on a plane. And we're going to give our answer as an ordered triple with x, y, and z. So the two types of problems we're going to see are, the first one is called the stair-step type problem, and these are actually a little bit easier because you're given one of your variables right off the bat, or it's just like a one or two-step equation to find that first variable. So in this first example, with my three equations, they already know that z is equal to 3. So I can do reverse substitution on this second equation, which only has y and z. And if I know what z is, that leaves me with just one unknown. So y plus 6 equals 5. And I find that y is -1. So there's my second variable. Now that I know z and y, I can plug both of those into my third equation at the top, where my only unknown is going to be x. Sorry, that should be a 2, not a 3. Got a little overexcited there. -2 times -1 is +2. So x plus 8 equals 9, and we get that x is +1. So there are my three variables, x, y, and z. So then my order triple is going to be 1, -1, 3. And we call these a stair step because my first one has the one variable, my second one has 2, and my last one has 3. So it kind of like makes a stair. Okay. Now when I don't have it so easy like that, if I've got three equations that have all three of my variables in it, I'm going to have to use this method. So what I'm going to start out by doing is eliminating one of my variables to get a two variable system. And once I am able to get the two variable system, I'll use substitution or elimination to get it down to one variable, and then use back substitution to get the other two. So let's see how that actually works, because that was a lot of words. I'm going to start by numbering my three equations, 1, 2, and 3. Now looking at my three equations, I want to determine what variable should I cancel. I'm looking at 1 and 2. I have a positive y and a minus y. So those will cancel really easily without me having to do any kind of extra multiplication. So from equations 1 and 2, I'm not going to do anything to change them. I'm going to combine them, everything on the right and everything on the left. And I get 2x, my y's cancel, plus 3z equals 5. And I'm going to call this equation that we made by combining 1 and 2, I'm going to call that A. I have this A equation with just x and z. So because I canceled my y's the first time, I need to do this again with a different pair of equations. So once you decide on the variable to cancel, we have to do this twice. So if I look at equation 1 and equation 3, I still have a positive y and a minus y. So that's also going to cancel nicely without any extra work. So I'm going to combine equations 1 and 3. Everything on the left and everything on the right. 2x, my y's cancel. 4z is 0. And I'm going to call this equation B. So now equation A and B give me a two variable system with just my x's and my z's. So now that I'm down to two equations with two variables, we can choose to use either substitution or elimination to solve. So I've got 2x and 2x, so I'm going to choose elimination. I'm just going to multiply this A by -1, my A equation, so all three pieces, and that'll give me -2x minus 3z equals -5. And then my B equation I'm leaving the same. And I'm going to combine everything on the left and everything on the right, and I've now found z is -5. So I found my first variable. Yay! It took a lot to get there, but I now have one of my three variables. So now I need to start using back substitution to get my other two variables. Now, I only know what z is. So when I'm plugging it into an equation, I need to make sure that that equation will only have one unknown. If I start plugging it back into one of my 1, 2, or 3 equations, I still don't know what y is. So even if I plug in for z, I'm going to have 2 unknowns, and that's not going to help me solve. So I need to plug this back into either A or to B, where I'm only going to have one unknown, and that being x. So you could plug it into A or to B. I'm just going to plug it into A. So 2 times x plus 3 times z equals 5. I'm going to scoot that up. So 2x minus 15 equals 5. Add the 15 to both sides, and we get that x is 10. So I now know x and I know z, so I can plug this back into any of my 1, 2, or 3 equations. I'm just going to choose number 1. So x plus y plus z equals 4. So y plus 5 is 4, and y is negative 1. So my ordered triple, 10, negative 1, negative 5. X, y, z. Okay. Let's practice that one more time. On this one, my second equation, if you look closely, doesn't have a z in it. So I already have one equation where I only have 2 variables. So again, I'm going to number these. And equation 2 only has x and y. So to make life easier for me, I should try to make another equation that gets rid of my z's. So if I'm picking between equation 1 and equation 3, I want to cancel my z values so that I can get it down to 2 variables and just have 2 equations with 2 variables, where 2 is one of my equations already. So on 1 and 3, I have z and 4z. So if I multiply this top equation by negative 4, that's going to get me negative 12x plus 4y minus 4z equals 0. And then that number 3 equation I'm going to leave alone. And I'm going to combine everything on the left and everything on the right. So here, I'm going to call that again equation A, because I combined 1 and 3. And I now have my 2 equations, equation A and equation 2, that only have 2 variables in them. And now I can choose to use substitution or elimination to solve for one of my variables. Well, both of my x's and my y's are already opposite signs. So here it just comes down to preference, but there is one that's probably going to be easier, and that would be our y values. I can cancel my x's, but it's going to be larger numbers and there's more room for error there. So I've got 10y and minus 2y. So if I multiply this equation number 2 by 5, I'm going to get 10y and minus 10y. So equation 2, I'm going to multiply by 5. And I'm leaving equation A the same. And I'm going to combine everything on the left and everything on the right. And I find x is 1. Here's my first variable. X is 1. Now, I want to plug that back into an equation where I'm only going to have one unknown. So I could plug it back into equation A or equation 2. I'm just going to choose to use equation 2. Either one is fine though. So 4 times x minus 2y equals 1. And I get that negative 2y equals negative 3. So y is 3 over 2. There's my y value. Now I'm ready to solve for z. So I can use either equation 1 or equation 3 to find z because I'll have one unknown. Equation 2 is not going to help me find z because it doesn't have z in it. So let's just go with equation 1. 3 times x minus y plus z equals 0. So 3 minus, and remember that's like 1.5, plus z equals 0. 3 minus 1.5 is 1.5 or 3 over 2. So I'm getting that z is negative 3 over 2. So there's my third value. So my ordered triple is going to be 1, 3 over 2, negative 3 over 2. Okay. Now our 3 variable systems, just like the 2 variable systems, our possible solutions are exactly one solution, infinite solutions when I end up with a true statement like 0 equals 0, or no solution when I get a false statement like 0 equals 3. Those are also possible outcomes of our 3 variable systems.